All right, this is 5.1 part 2. This will cover the last three properties for exponents. But one thing I wanted to cover really quick is if we had x times x times x on top and x on the bottom, remember whenever we do this we can cancel, as long as we're multiplying everything, then we can cancel items. So there's as long as we do one on top as we do one on the bottom. So I would actually end up with x squared in this case. All right, so let's go ahead and look at the first one. This is called a quotient of powers. So it's x to the fifth over x to the third. So remember, just like the rule we just did, if I wrote this out in expanded form, I have 5 factors of x. So 1, 2, 3, 4, 5. And on the bottom, I have 3 factors of x. So whenever I have one on top, one on the bottom that I cancel, as long as I have one on top, one on the bottom, I can cancel. And so in this case, I would actually be left with x squared. A rule that we might use for this, remember when we were multiplying items, we actually added their exponents. So when we divide, we're actually going to subtract their exponents. So 5 minus 3 would give us squared. So a rule we might use for this one would be a to the m minus n. Now one important thing you need to remember is that the top number needs to be first and the bottom exponent is going to be subtracted second. So if we did a quick example, first thing is that we need to make sure that they have the same base. So in this example, we're going to do the a's. So if I could subtract those, I'm going to end up with a to the 5 minus 3, b to the 2. Remember, there's not an exponent, there's an invisible 1 there. 2 minus 1. So my answer is 5 minus 3 is 2. So a squared, 2 minus 1 is 1. So my answer is going to be a squared b. Okay. So on the next example where it's 4 to the 6, now remember, I'm not going to subtract 4 6 because that's actually, I'm going to treat that just like I would a fraction. So when I treat that just like a fraction, I have to reduce it. So you have to ask yourself, what will go into 4 and 6? And the answer is 2. So I can divide them both by 2. So 4 divided by 2 is 2. 6 divided by 2 is 3. And then my variables, I could do 8 minus 5, because remember I'm dividing. And I get y to the 3 minus 2. So I end up with 2/3 x to the third y. Okay? And that would be your final answer. Okay? All right, the next one is, remember that whenever we're writing a fraction, if I have the exact same thing on top as I do on the bottom, then my answer is 1. Okay? So when you look at x to the third over x to the third, if you notice, they're both exactly the same thing. If I did the expanded form, I had 3 factors of x over 3 factors of x. And I actually have everything that cancels out. If I subtracted my exponents, I ended up with x to the 0. Well, when everything cancels out, there's still an invisible 1 here that we can multiply it by. So anything to the 0 power is just going to be 1. Okay? Anytime you have something to the 0 power, it's just going to be 1. Okay? All right. Negative exponents. Now, I will say this is one that a lot of my kids have a lot of trouble with. So if I followed this out to the same rule, I have x to the 3 minus 5, which gives me x to the negative second. Okay? Now, negative x, we cannot have any negative exponents, and all of our exponents should end up positive. If I do have a negative exponent, then you need to change its position in the fraction. So for example, if it's in the numerator, you're going to move it to the denominator. If it's in the denominator, you're going to move it to the numerator. So this one right now is in the numerator, so I'm just simply going to change its position since it's, I refer to this as upstairs and downstairs. So it's in the top part of the fraction. I'm going to move it to the bottom part, and I have to put a 1 on there as a placeholder. Another way to look at this is if you've ever played Risk, and you have armies that battle against each other or tug of war, you know we're going to knock out 3 x's up here, we're going to knock out 3 x's on the bottom, and be left with, if I knock out 3 x's here, I get 1. If I knock out 3 x's here, I'm left with x squared. And I had more x's on the bottom, so that's where they're going to end up. Okay? But if you have a negative exponent, remember if I have just a plain whole one, it's over 1. So right now it's in the top, so I would simply move it to the bottom. And I have to have a 1 as a placeholder. Okay? This one, since it's in the bottom, it would simply move to the top. Okay, and I don't need a placeholder on the bottom for whole numbers. Okay. All right, next example. Actually, the next rule. This one's called a power of a quotient, and all this one means is, remember, this power means I got to do x over y times x over y times x over y. And if you remember from the previous video, whenever I'm multiplying x times x times x times x gives me x to the third. Y times y times y gives me y to the third. So a quick rule that we can write is, whenever you have an m, this is kind of like the distributive one. You can raise both of these to that power. So it's going to be a to the m over b to the m. Okay, and I can't simplify those any further because remember, they have different bases. So let's do some examples. So the very first one, remember, I can put this over 1. And I suggest when you're doing these that you multiply straight across. So x to the 8th times 1 is just going to give us x to the 8th. 1 times x to the 3rd is going to give us x to the 3rd. And then since I'm dividing, I actually subtract their exponents, and I end up with x to the 5th. Okay. So the next one, remember, this one would actually go to 1. Anything with the 0 power would give me 1. And the only time I really have to put anything is if I need a placeholder for the top. So on the top, x to the 5th minus 4, and then I end up with y squared. So 5 minus 4 is 1. I don't need that one. Y squared as my final answer. Okay? All right. Next example. There's a couple ways to do this. Here would be my suggestion. Go ahead and distribute this. Remember from the first video, we're going to distribute this. So I get x. Whenever I have a power to a power, I'm going to multiply. So 4 times negative 3 gives me negative 12. 7 times negative 3 is going to give me y to the negative 21st. And remember, I don't want any negative exponents. So all I have to do is, these are in the top of the fraction right now, so I just simply move them to the bottom. This is in the top of the fraction. I simply move it to the bottom. And I have to put, since everything went underneath, I have to put a 1 underneath it for a placeholder. Okay? All right, so let's go ahead and take a look at the bottom one. I have 5 over 20, or 5x to the 3rd y to the 9th over 20 x squared y to the negative 2nd. Now, first of all, before we even start, the 5 and the 20, remember, are not exponents. So I can only simplify those. So what will go into both 5 and 20? Well, 5 will go into both of them, so I can divide this one by 5 and this one by 5. So when I'm doing this, 5 divided by 5 is 1, 20 divided by 5 is 4. And then the rest of these, the other things that I take care of is the negative exponents, remember, change their positions. So I'm just going to simply move it upstairs and get rid of that negative exponent. Okay? So then once I've taken care of moving things and simplifying my coefficients, now I just take care of my x to the 3rd over x squared. And remember, I subtract their exponents. And since these are on the same side, they're not across that fraction bar, it's going to be y to the 9 plus 2, because it's just like multiplying. Okay? So I don't need the placeholder because this is going to end up being x 9 to the, or y to the 11th over 4. Okay? All right. Next ones. Now, as these get more complicated, you need to make sure that, let's go ahead and, first of all, I suggest taking care of any negative exponents. So we're going to move all negative exponents. Okay, so the only one we've got is this one, and I'm just simply, remember, going to move it up on top. Okay, remember there's an invisible 1 here. So let's go ahead and multiply all of our coefficients. So 1 times negative 7 is going to give me negative 7. X, I don't have an x to multiply it to, so it's just x. Y, and remember I got to add these. Y to the 9th plus, or times y squared times y. I add their exponents, so 9 plus 2 is 11, plus more gives me y to the 12th. Next one, 3 times 21 is going to give me 63. And the only thing I have is an x to the 5th. Okay? So we have to simplify our coefficients, and a 7 over 63 is going to give me a negative 1/9. X over x to the 5th, remember I have to subtract those, and I always view it as I got more x's on the bottom. So that's where my x's need to end up. And the top gives me y to the 12th. Okay. So go ahead and pause the video at this time and go ahead and try the last you try, and then we'll work on it together. All right, so if you remember, we're going to multiply. 12 times 7 is going to give me 84. And then 7 times 4 is going to give me 28. So when I'm doing this, and if you want to, you can go ahead and simplify that. Like, I know 7 will go into both of those, so I end up with 12 over 4. And then 12 over 4 will simplify again, and I end up with 3. So then you can take care of your variables once your coefficients all simplified as far as it can go, or you can do it like we did the previous one. That I don't have any negative exponents. X times x to the 5th is x to the 6th. Y times y squared is y to the 3rd. X to the 4th doesn't have anything on the bottom. And then it's just y. So my final answer is going to be 3. I have to subtract them and I get x squared. Subtract them and I get y squared. Okay. So a quick recap. Remember, whenever I multiply items, I'm actually going to add their bases. Add their exponents. When I have a power to a power, I'm going to multiply them. Whenever I have anything to a 0 power, the answer is 1. Whenever I'm dividing and they have the same bases, I actually subtract their exponents. Whenever I have a fraction and it's both raised to the same exponent, I'm going to raise both of them to that same exponent. And then when I have negative exponents, I actually change its position. So if it's in the bottom, I move it up. If it's in the top, I move it down. Okay. Make sure you view the video in there because this lesson really has a unit. Oh,